we need to do this integral. We're going to use these integral formulas over here. We're going to match this one because we have the square root in the bottom. So it's going to be that one. It's going to be arc sine of something. Whenever you use a math or science formula, it's not so simple. You might think, oh, just do that, just boom, write down the answer. Well, you got to do first, you got to make this look like that. Once you match it, then you can use the formula. So it's a little trickier than you might think. I call it plastic surgery. We got to give this a new look so that it looks like this guy, then we can use the formula. So what do I mean? It looks like this guy. Well, see, this guy has something squared minus something squared in the root on the bottom. So I'm going to make that 1 squared minus. Now, how can you write that as something squared there? Well, that's x to the 6th squared. That'll become x to the 12th, huh? So I think, oh, so that's my 1 squared minus u squared on the bottom. So my u is x to the 6th, isn't it? Right? Here's my u. X to the 6th is my u. Because you got to make it something squared minus u squared. So, okay, so then take the derivative, du, we're doing a u sub here. This will be 6x to the 5th, and then multiply both sides by dx. Boom. So du is 6, well, a little more room here, 6x to the 5th dx. Now, let's start rewriting this integral. So we're going to bring down this integral. We have the integral of 1 squared minus u squared. On the top, we have x to the 5th dx. So I'll just write it x to the 5th dx. Now, what is x to the 5th dx? Well, you can see it coming, huh? Multiply both sides by a 6th. Boom. And there it is. X to the 5th dx is 1/6 du. So x to the 5th dx will be 1/6 du, won't it? So then the integral becomes 1 squared minus u squared. X to the 5th dx, that's 1/6 du. Yank that 1/6 to the front, so it's 1/6. The integral of du over 1 squared minus u squared. Now it matches. Now it looks just like this one, doesn't it? See how it's an exact match with that one? So that means once you get it looking the same, you can use the formula. So we go, okay, don't forget the 1/6 in the front, times, and then this integral piece will become, what is the integral equal to? Arc sine of u over a, plus a constant, of course. And then, well, what is that u and a? Well, we already know the a is 1, right? Because it's 1 squared, it's something squared, 1 squared there. And the u, that's x to the 6th. So this is x to the 6th, oops, over 1 plus a constant. And you can rewrite that if you want. You can say, well, look, that's just 1/6 arc sine of x to z. We don't need the over 1 plus a constant. There we go. And that is indeed the answer, 1/6 arc sine of x to the 6 plus a constant. So the moral of the story is if you're going to use a math science formula, you got to first do plastic surgery, give it a new look so that it matches the form of the formula. Then you can use the formula. So I said, okay, I got to make it something squared minus something squared. So 1 minus x to the 12th, that's 1 squared minus x to the 6th squared. And so clearly that's my u. My u is supposed to be u squared down there. Must be x to the 6th. Then I took the derivative and got the x to the 5th dx alone. It's 1/6 du. So the x to the 5th dx on the top became 1/6 du. The bottom square root of 1 minus u squared. Put the 1/6 in the front, and then we got a match. Now that looks like that. So we can use the formula. It is arc sine of u over a plus a constant. The u is x to the 6th. The a is 1. And there we go.